All KCA students, this is David Ngunda again from KCA. So today we'll be covering a full lab configuration. So in this lab, we'll be covering some topics such as VLAN, trunk, OSPF, DHCP, DHCP relay, ACL, and SSH. So this is the topology that we'll be working on. So basically we have three routers. We have Dallas router, Houston router, Austin router. Each router will have a switch connected to it on the G00 interface. And then, for example, in Dallas, we have three VLANs connected to it. Houston, we have two VLANs. So Dallas VLANs will be 10, 20, and 30. And also Houston VLANs will be 40 and 50. And finally, Austin router will have a switch which will have two VLAN connected to them. We have a VLAN 60 and VLAN 70. And after that, we're going to configure DHCP on each of the routers so that the PCs from each VLAN will get IP addresses dynamically. Now, after configuring the VLANs on the PCs, we need to set up a DHCP relay. So essentially, the users from Houston will get the IP address from the DHCP configure in the Dallas router. And then also, but Dallas router will configure DHCP for its own VLAN, so no relay needed there. And then also Austin router, we have basically two relays. So VLAN 60 will get a relay from Houston router, and then VLAN 70 from Dallas router, okay? And also, in order to establish the routing, we're going to cover OSPF dynamic routing protocol. And at the end, we're going to set up our SSH on some of the routers and also configure access control lists to filter basically which VLAN or which user IP will be allowed to remote into the router through SSH. All right, so let's move back to our packet tracer and get started with our topology configuration. All right, so here we are. This is our packet tracer topology. So we have VLAN 10, 20, and 30 in Dallas, and also 40, 50, Houston, Austin routers will have VLAN 60 and VLAN 70. So let's get started with the Dallas router first. So let's start with the switch. So we're going to name this switch Dallas switch. It already has a name on it. One moment, guys. I need to disable DNS on it. In the meantime, let's start with the Houston VLAN. So on this Houston, let's go to the switch, configure terminal. We can give it a name, host name, Houston switch, and we need to create the VLANs. So to create the VLAN, the keyword is just VLAN, and then you give the VLAN number, VLAN 10. Sorry, it's a VLAN 40. So we have to remove a VLAN. You just have to say no VLAN 10. It's gone. And then let's create VLAN 40. VLAN 40. Let's name it LAN 40. Okay, that's how I'm going to name it. And then let's create a VLAN 50. LAN name LAN 50. Okay. Now, next we have to set up some port range. So on the switch, this switch particularly has 24 switch ports. Do show IP interface brief. As we can see, we have a fast Ethernet 01 all the way to fast Ethernet 24, and we have 2 gigabyte Ethernet. So we're going to use the G01 as a trunk going to the router, and then the remaining here will belong to VLAN 40 and 50. So we'll take a range, interface range, FA01 through 14, and we will associate that with VLAN 40. So we'll say switch ports, mode access, and then switch ports access VLAN 40. And then we'll take interface range FA0/50 all the way to 24. We'll say switch port mode access switch port access VLAN 50. Okay. Now let's create what we call a native VLAN. So we'll say VLAN, we can give it a number 99. Just the last one. Name, let's name it native. Okay. Now, after assigning the switch ports to the particular VLAN or respective VLAN, we need to verify that. So let's do show VLAN brief. So we've got our VLAN 40, VLAN 50. So, okay, VLAN 40 takes care of fast Ethernet 01 all the way to 14, and VLAN 50 fast Ethernet 015 all the way to FA 024. So, which means if we plug in a PC on any of the ports ranging from FA 015 all the way to FA 024, they will definitely belong to VLAN 50. And then from FA01 all the way to 14 will definitely go to VLAN 40, which we call LAN 40. All right, thank you. All right, so now next we need to take a look back. Always refer to the topology so that we don't make mistake on the switch port. So now G01 from the switch will go to the router, Houston router. So we have to configure that as a trunk. So trunk allows different VLAN tags to go through it and in order to reach the sub interfaces that we will create on the router side. So interface G01 will say switch ports mode trunk, switch ports trunk allowed VLAN will say 40 and 50. And then we need to change the native VLAN, switch port trunk native VLAN 99. Okay. As of now, since G01 is a trunk port, we need to make sure G00 is enabled with encapsulation on the sub interfaces in order for the trunk to be fully established. Okay, so now we have some network addresses. So for VLAN 40, we have 192.168.0./24 and VLAN 50 192.168.50.0/24. So we need to pick the first usable address for the case of this lab. Now, always, it can be the last usable, but we chose to use the first usable IP address from each of these VLANs in order to make them as the default gateway or the router's interface IP. Okay, so now let's go to the router in Houston. We're going to name it Houston router or Houston. Configure terminal. Hostname Houston. Let's disable DNS, no IP domain. Lookup. Okay, now we'll say interface G00. Let's turn it up. No shutdown. Interface G00. That's 40 for VLAN 40. Now we need to do encapsulation. That's 1Q 40. IP address 192.168 at 40.1 255.255.255.0. Interface G00.50. IP encapsulation first. If you apply the IP address without putting the encapsulation, you get a warning message. Let's try that out. So IP address, for instance, 192.168.50.1 255.255.255.0, you get this warning message. Configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of IEEE AO2.10, which is IEEE AO2.1Q. That's what we call the encapsulation.1Q. Okay, so we have to start by doing this encapsulation.1Q and the VLAN tag, which is 50. And then after that, we can call back the IP address and then you should be able to take it. So now when we do show IP interface brief, we can see that both our sub interfaces, G00.40 and G00.50, have IP addresses assigned to them. Good. All right. So now I think we're pretty much almost done here. Now let's go to Dallas now. Dallas router. We have to do the same thing. We have to configure the VLAN in the Dallas router and then assign the port to the interfaces. So here we are in the router, the Dallas switch first. Show VLAN. So in Dallas, the VLAN and the port allocation have been already configured. So we have VLAN 20, VLAN 10, VLAN 30, which have the IP address, so the interface ranges already assigned to the respective VLANs. So FA01 all the way to 12 belongs to VLAN. FA01 to 7 will be part of VLAN 10. FA08 to 12 will belong to VLAN 20. FA014 all the way to 24 will belong to VLAN 30, and 13 has been left out. Okay, that's okay. That's the design for this topology. Now, how do we verify if trunk is already configured? Show interface trunk. So we have an empty response, which means it hasn't been configured yet. We can do show run pipe section trunk. Show run pipe section trunk. So trunk has been already set up, and we can see there is a switch port trunk allow VLAN 10, 20, and 40 and 30. All right, so it's been already configured. Now, what I'm gonna do is I'm going to erase the startup config from this switch, so that I can start it over for you guys to see it. Okay, so now I'm reloading this switch in Dallas. After this comes back up, I will be able to basically reconfigure it from scratch. Let's do the same here. Show interface trunk. Show VLAN brief first. Okay, this switch is ready to go, so let's get it done. Config T. Let's say VLAN, as you guys can see, VLAN 60 and 70 have been already created in this switch. So let's first start by giving a name, host name, Austin switch, interface range, FA01 through 14, switch port mode access, switch port access VLAN 60. Interface range FA015 to 24. Switch port mode access. Switch port access VLAN 70. Interface G01. Switch ports mode trunk. Switch port trunk allowed VLAN 60 and 70. All right, so now let's create our native VLAN, VLAN 99. Let's name it native. Interface G01, switch ports, trunk, native VLAN 99. All right, so let's go back to the switch, the router in Austin. We're going to configure the sub interfaces going to each of the VLAN. All right, so now in Austin router, let's configure it together again. Config T. Let's say no IP domain. This command is very important. If you don't disable DNS, if you tap a wrong command by accident, the router might hang for a very long, maybe like a minute or two. So to avoid that, we need to disable DNS. No IP domain lookup. Okay. Host name Austin router. Now we can say interface G00, no shots. Interface G00.60 for VLAN 60, encapsulation.1Q 60, IP add 192.168.60.1, 255.255.255.0. Interface G00.70, encapsulation.1Q 70, IP add 192.168.70.1, 255.255.0. All right, do show IP interface with. All right, so we've got our interfaces assigned with IP addresses. Okay, now let's do one more thing. Let's see, we have some serial interface there. So Austin router goes to Dallas router to serial 001, and it goes to Houston router over serial 000. So interface serial 001, no shots. We can put description, link. We can say Austin to Dallas. IP add, this is a 2 network. 2.2.2.2.255.255.255.252. Interface 0000. IP add 3.3.3.2. 255.255.255.252. No shots. Description Austin to Houston. To show IP interface with. All right. So we got our two IPs. The interface's status is down, manually down, which means we already applied the no shot on one side. Now, after we configure Dallas with the serial interfaces, turn them up, then they can go up. All right. So now here we go. Dallas router config T hostname Dallas router, no IP domain lookup. Interface serial 001 going to Austin. Let's take a look. So serial 001 goes from Dallas router to Austin router. Okay, back to the command line. We'll say IP add 2.2.2.1 255.255.252 interface serial 000 description. Say Dallas to Houston. One 255.255.255.252. No shots. Now, Dallas, guys, is 3 VLAN. We have VLAN 10, VLAN 20, VLAN 30. Now we need to configure the sub interfaces. Interface G00.10 for VLAN 10 encapsulation dots 1Q10 IP address 192.168.10.1 255.255.255.0 interface G00.20 encapsulation dots 1Q20 IP add 192.168.20.1 255.255.255.0 interface G00.30 IP add 192.168.30.1 255.255.0. We're missing the encapsulation. Encapsulation dots 1Q 30. And then let's call back the IP address. And let's make sure we turn on G00. No shutdown. And all sub interfaces will go up. Do show interface with pipe exclude unassigned. So we've got all IP addresses. So the sub interfaces are all up. We just need to set up the what we call the serial interfaces. Interface 0001, no shots, and do show PINT with pipe exclude unassigned. Now, which one is up? Let's double check. Okay, serial 000 is up, but serial 0001 is now up. 000 is down because Houston is not set up yet. So let's go back to Houston. In Houston, we did actually configure G00. Let me move myself around. G00, that's 40 and 50. Now let's do interface serial 001 IP add, which is pointing to Dallas 252. No shots. Since it's pointing to Dallas, we can set a description there. We'll say Houston to Dallas. Okay. All right. Interface serial 000. No shots. IP add 3.3.3.1 255.255.255.252. Description Houston to Austin. There we go. All right. Do show IP, int brief. Okay, we got the serials app and the sub interfaces app. Good. Now comes the DHCP configurations. Back to the topology. As we said, VLAN 10, 20, and 30 from the Dallas router should get the IP addresses originating from the Dallas router itself. So no relay needed. Let's start with the easy one. IP DHCP pool. We can call this one VLAN 10. Network 192.168.10.0, 255.255.255.0. Default router 192.168.10.1, and DNS server 192.168.30.20. For this lab, we set up some DNS server at 192.168.30.20, which is in VLAN 30. And then we can do some exclusion. IP DHCP excluded the address 192.168.10.1. Let's exclude the first 24's IP. That 10.24, and I'm going to repeat the same for VLAN, all the VLANs, okay? 20, and let's do it for VLAN 30, because Dallas will also have a DHCP for Houston lanes, so we have to do for 40 and 50 as well, and also 70 for Austin. Let's do for VLAN 50. So let's just exclude everything at once. And now lastly will be 70 for the Austin lane. Good. Now IP DHCP pool VLAN 20. Network 192.168.20.0, 255.255.255.0. Default router 192.168.20.1. DNS server 192.168.30.20. Good. Exits IP DHCP pool VLAN 30. Network 192.168.30.0, 255.255.0. Default router 192.168.30.1, and our DNS server is 192.168.30.20. All right, so now we need to go back to the, first of all, let's check do show app exclude unassigned. So we've got the 3 VLANs assigned, and we have the serial assigned and up and running. Now we need to go back to the switch in Dallas just to make sure that everything is back in place. Show VLAN brief. We've got VLAN 10, 20, and 30, but notice that all the switch ports are assigned to the default VLAN, which is VLAN 1. So we need to make sure we separate them. So FA0127, we want to assign them to VLAN 10, and then FA08 through 14, we want to assign them to VLAN 20, and the remaining to VLAN 30. Config T, no IP domain, lookup, hostname, Dallas, switch, interface range, FA0127, switch port mode access, switch port access, VLAN 10, interface range, FA08, 8 through 14, switch port mode access, switch port access, VLAN 20, interface range FA015 through 24, switch port mode access, switch port access VLAN 30. We can create a VLAN 99, name it native, and then we can also enable the trunk, interface G01, switch port mode, trunk, switch port, trunk, allowed, VLAN 10, 20, 30, switch port trunk, native VLAN 99. Okay. By doing this, we should be able to go back to the PCs and request an IP address via DHCP. Okay. Now let's go to PC on VLAN 10. Let's open the first PC. Go to command prompts. Command will be ipconfig /renew. Invalid command. What's missing? ipconfig was mistype. Okay, requesting now. Okay, success. We got an IP address from DHCP 192.168.10.25. Subnet mask of /24, 255.255.255.0, 192.168.10.1, which is the default gateway, and the DNS server which we configured. Okay, good. Second PC, let's try the same. ipconfig /renew. Good. Let's go to visit VLAN 20. Make sure we get the IPs within the VLAN 20 network. ipconfig /renew. Okay, we got an IP. VLAN. Now let's try VLAN. Second PC of VLAN 2 ipconfig. Second PC of VLAN 20 /renew. Requesting an IP. Good. VLAN 30 also we should get the servers fakebook.com and kca.com. Those one have a static IP. Okay, that was a mistake. Let's fix it. Command prompts. ipconfig /renew. 30. Good. And then we can pick a second PC. ipconfig /renew. Great. Let me close all this tab. All right. Okay. So now, so Dallas router is set up as far as DHCP. All the PCs can get an IP address dynamically. And also now, there are some requirements. As we can see here, VLAN 60 in Austin must get an IP address from Houston. So we have to go to Houston and create a pool for VLAN 60. IP DHCP pool VLAN 60 network 192.168.60.0 255.255.255.0 and then default router 192.168.60.1 DNS server 192.168.30.20 and then IP DHCP pool excluded address 192.168.60.1 192.168.60.24 all sets. All right, so now we have that done. Now, this is how DHCP operates. So whenever you configure a DHCP, it's designed to automatically assign IP addresses to the remotes to your network. So now, if your DHCP server is on a remote router, then you need to use what we call DHCP relay. So basically, you have to tell your LAN that your DHCP server is on a remote network. We do that by applying what we call the IP helper address on the interface that goes to the actual VLAN that needs an IP. So for the case of the Houston router, we can see that their DHCP server for Houston is in Dallas, right? So we have to pick the IP address reachable of the Dallas router, for example, 111 for this case, and use it as IP helper on the sub interfaces of each VLAN in VLAN 40 in the Houston router. So we go here, interface. First of all, we need to do show IP routes. We can see that VLAN 40 and 50 are configured. There's a route going to the sub interfaces G00.40 for VLAN 40 and G00.50 for VLAN 50. So we have to go to each and every sub interface, configure remotely or with the DHCP. So G00.40 will say IP helper address 1.1.1.1, which is the network or the IP address in the Dallas router, and the interface G00.50 IP helper address 1.1.1.1. All right, so VLAN 40 and 50 are set up pretty much, and we go to Austin config T interface G00.60. As we know, VLAN 60 in Austin is expecting IP addresses to come from the DHCP server configured in Houston. So we'll say IP helper address 3.3.3.1, which is the IP address of the Houston router, interface interface G00.70 IP helper address 3.3.3.3.1. Good. Oh, no. VLAN 70 is going to be the Dallas router. So we say IP helper address 2.2.2.1. Great. Now we've done that. This is how DHCP works. So when we go to Dallas router, let's say do show run section DHCP. We have configured some pools here. We have a pool for VLAN 10, VLAN 20, VLAN 30. Now, Dallas is also expecting a pool for VLAN 70, 40, and 50. Let's go ahead and configure them. We say IP DHCP pool VLAN 40 network 192.168.40.0 255.255.0 default router 192.168.40.1. This should be a typo there. And DNS server 192.168.30.20, and then IP DHCP pool VLAN 50, default router 50.1, and the network. So the DNS server and network will say 192.168.50.0, 255.255.255.0. Now, do we do the 40? Yes. Okay, good. And then IP DHCP pool VLAN 70, network 192.168.70.0, 255.255.255.0, default router 192.168.70.1, DNS server 192.168.30.20. All right. Now, do show run section DHCP. Now we've got the pool for VLAN 10, 20, and 30. Let's disregard those ones. They belong to the Dallas router. So let's focus on the remote ones, right? So the pool IP DHCP pool for VLAN 40 belongs to the VLAN that is in Houston. And also VLAN 50 network 192.168.50.0 also belongs to the VLAN that is also in Houston. And then lastly, we have VLAN 70, which is the VLAN in Austin. Okay. So now, how does the router knows, or the DHCP knows, that where to go in order to find VLAN 70 or VLAN 40 and 50 inside the IP routes? So when we do show IP routes, we can see that we don't have any routes going to any of the VLAN 50, 40, or 70, right? So it only knows 30, 20, and 10. That's why those VLAN get IP addresses, right? So now we have configured IP helper on those remote routers. So now we need to make sure there is a route. Once we set up a route between Dallas, Houston, Austin, then DHCP can reach those remote VLAN and assign IP addresses automatically. So now let's set up the route. So we're going to use a protocol called OSPF, Open Shortest Path First, OSPF. Okay. So let's configure it. So do show, let's do it. Do show IP interface brief pipe exclude unassigned. So as we can see here, we have some network. We have network for VLAN 30, 20, 30. These are the IP addresses, usable addresses from those network, but they're just coming from the, so I know which network they're coming from, okay? So we'll say router OSPF, let's give a process number 1, for example, and let's advertise those network. We can say network 1.1.1.0 wildcard bit 0.0.0.0.3 for the /30, okay? And we need to specify the area. Let's put the backbone area 0 on all the 3 serial interfaces. So area 0, and then we have a network of 2.2.2.0.0.0.0.3 area 0 as well. Now, yeah, area 0. Now we need to do the VLAN. So whenever you configure a router, right, the OSPF on a router, each router needs to advertise its own directly connected network. So Dallas router is connected to 2 VLANs and 2 serial interfaces. Now we're going to put the VLANs in area number 1 for the Dallas router. So we're going to say network 192.168.10.0.0.0.255 area 1. So far, we're not doing route summary, so we just advertise route by route, 20, and then 30. Okay, at this point, do show IP routes. We're still not seeing those remote routes, right? So there is no routing still, even though Dallas has been basically configured with OSPF, but it has to wait for the neighbor to also enroll into OSPF and also make sure that they're sharing the same network on the serial interface and the same area number in order to establish what we call the neighborship adjacency. Okay. All right. So let's go to Houston and try that. As we can see now, Dallas only knows about its directly connected network. When you see the C here, the C represents all the directly connected network, which is here, connected. And then the L is for the local. So from each network, we pick one single IP that we assign to the router's interface. That's what we call the local IP. Okay. All right. So let's go now to Houston. So in the Houston router, here we go. We have to configure OSPF as well. Router OSPF2, for instance. Network 192.168.40.0.000.255, say area 2 for Houston, and network 192.168.50.0.000.255 area 2. So in Houston router OSPF, we're going to use area 2 for the LAN. It's not a general rule, it's just a preference, okay, for the purpose of this lab. So now, as of now, there is no neighborship established. So Dallas and Houston are not neighbors yet. Until Houston and Dallas realize that or notice that they are sharing a common network on these serial interfaces, they are directly connected there, and then the OSPF is configured with the same area number, then they will become neighbor. Once they become neighbor, what's going to happen? Houston will basically present its network to Dallas, and Dallas will introduce its TWI VLAN to Houston, and then they will converge their routing tables. Okay, so let's check that out. So we go to Houston. We're going to, as soon as we say network 1.1.1.0.0.0.0.3 area 0. Enter. We have to wait a few seconds. We should receive a notifications that talks about neighbor adjacency, which is the LSA type 5 message from OSPF. So link state advertisement. So we have OSPF 5 adjacency created on the OSPF neighbor. All right. So now we can do this. Do show. Now let's start going back to Dallas. Previously, we did a do show IP routes, right? We could see that Dallas didn't know about the remote network. So now let's try to do that and see what happens. Do show IP routes. Now we can see that at the bottom here, when you compare with the previous outputs, right? Now with OSPF being established, Houston has shared his directly connected network, which is VLAN 40 and 50 advertised inside the router OSPF process. Now that Dallas knows about these two, this will permit Houston also to know about the TWI VLANs. Do show IP routes, the TWI VLAN of Dallas. We have OSPF, so the O stand for OSPF, okay, and IA stand for inter-area connection domain, right? So Dallas has area 1 and Houston has area 2. So those routes have been learned dynamically from different area. That's why we have the IA next to the O. All right. And also it tells you the next hop IP, which is connected to it. And this is the cost and the administrative distance for OSPF. I'll explain in the class, guys. Okay, this is just a lab for you guys to use it as a, demonstrations, to use it for your future labs when you're working on yourself. All right. So now let's go back to the PC in Austin, make sure that we can get an IP. So we have one IP, one PC representing the VLAN 40. A total should be 254 usable IPs, but we're using just one for now, ipconfig /renew. Let's see what happens. Okay, so now Dallas is about to reach Austin network VLAN 40. As a result, the DHCP relay is working. Let's check that out also on VLAN 50. Okay. ipconfig /renew. Great, working. Now we need to do the same. As of now, if we do ipconfig slash renew in Austin VLAN 60, for example, the DHCP should fail. ipconfig slash renew. As we're seeing, it's hanging and it's going to fail eventually. All right, so now we need to also onboard the Austin router into the OSPF protocol. Router OSPF 1 network 192.168.60.0 area 3 network. Let's just call the previous one and change the network address to 70. And then now once we basically set up the network of the Houston or Dallas router 2.2.2.0.0.0.0.3 area 0, and we need to do the same for Houston network. Now we got some adjacency with Dallas, which is good. Now let's do it for Houston network 3.3.3.0.0.0.0.3 area 0. Okay, so now we know that we have our neighbor adjacency with Dallas, which means at this moment, Dallas should learn dynamically all the network from Austin, and Austin should also be able to learn VLAN, not only VLAN 10, 20, and 30, including the Houston network, right? So do show IP routes. Let's take a look here. So now Austin knows about the 3 VLAN of Dallas, including the 2 VLAN of Houston, because Houston and Dallas are neighbors. And once we go to Houston, we should be able to see that Houston is also learning do show IP routes, is also learning 60 and 70. Very good. All right, working. Now let's also establish OSPF between Houston and Dallas and Austin. So we go back here, router OSPF to network 3.3.3.0.0.0.0.3 area 0. By doing so, now Austin should next become neighbor with Houston through their serial interface or to the network 3330. There we go. Now we go back to Austin and try to make ipconfig renew. We're getting the IPs, good. And then we go to VLAN 70, repeat the same exercise. ipconfig slash renew. Now we're going to have the 70 IPs, great. So now at this moment, we have successfully configured OSPF. So to verify the OSPF, we can also do show, or we can go to privilege exec modes, show IP routes, OSPF. Now it gives you all the network learned via OSPF. Okay, so when you have a single O like this is all the network learned through OSPF within the same area as Dallas router, but these are all the network learned dynamically, but residing in different area. All right, so now I think we're pretty much done. Let's go back to the nodes and see what else needs to be configured. So we have done VLAN, trunk, OSPF, DHCP, DHCP relay, SSH, and ACL, and SSH. Okay. Now let's go back here. Let's say let's configure Austin to be accessible remotely using the protocol we call SSH. So we say we already have a host name on it, IP domain name. IP domain name, we can call it kca.com. Let's set up a username Austin privilege 0/15 secrets KCA 123. Crypto key generates RSA. Let's put the modulus to 1024. And then whenever you connect to SSH, you go over the virtual lines, the line VTY. So line VTY 0 through 15 transports transport input SSH and login local. Now let's go to, for example, a PC in Dallas and try to SSH to the Austin router. SSH-L username was Austin, and then the Austin router will be 2.2.2.2. The password will be KCA123. Enter. Now we're in. Let's also go to Houston and try the same. SSH-L Austin IP address 222 KCA 123, and we're in. So this is a very big security value. You don't want to allow anyone to access your router to SSH, so you need to restrict access. So that's why we need to involve what we call IP ACL, access control list. Access list, let's define a standard access list. Access list 1, say permits. Let's just permit VLAN 10, 192.168.10.0 wildcard bits 255, enter. So whenever we permit a network inside the access list, there is what we call an implicit deny. So indirectly, we basically blocking everybody else. Okay, we don't have to explicitly say that. We don't have to explicitly say deny any. But once we permit one, when we have a statement that permits one network, there is an implicit deny for the remaining of the network. Okay, so now we go back. We have to apply the ACL inside the line VTY. So we say line VTY 0 to 15. We say access class IP access class, and the number was 1, and we say in. Sorry, I think there's a typo there. Access class 1 in. Okay, so by doing this, only VLAN 10 users should be authorized to SSH. Let's exit and try again. So VLAN 10, we can log in successfully. Let's go back to the Houston router where we were able to log in recently, right? It was on VLAN 50, I think. Let's exit since there was an existing session. We'll say IP, no, SSH. Let's just call back the commands. SSH-L Austin and IP address 222, we get connection refused by remote host, okay? Let's go to Dallas and try to SSH from a different VLAN. Now we are trying to SSH from VLAN 20. We'll say SSH-L. The username was Austin, IP address 222. Connection refused by remote host. So now we have an ACL access controls list 1, which is permitting only VLAN 10. Now I'm going to do this. I'm going to add a single host from VLAN 20. Now every user in VLAN 20 should be able to SSH, but let's just pinpoint only VLAN this single IP 192.168.20.25 in the ACL. So we go back to the Austin router. We just need to do access list, same number, 1 permits. Let's permit the host 192.168.20.25. 20.25 do show access list. Now we have two statements. Access list one, first statement is permitting this. We have two matches, and now we just added a new statement, 25. So now on VLAN 20, only PC 25 should be able to SSH. It will prompt us for the password, KCA123, and we're in. All right. Good. Now we did set up our DNS server, right guys? We have a DNS server called kca.com and we have another server called fakebook.com. Let's try to see if we can access them through the web. We have a small web simulation here, or emulation in this packet tracer. It takes a little bit longer to load. So while it's loading, guys, I need just to explain you a little bit of access control list. So access control list is basically a list or a set of rules that you define whether. So we have two types. We have the standards and the extended ones. So the standard basically, once you block, let's say a network, it will block access to anything from that particular network. However, when you use extended access control list, you can literally block or apply some filter to your ACLs. Let's say you can say, I'm going to block VLAN 20 from not SSHing or not connecting to my router to SSH, and also permit them only to do the web access, right? So it's very powerful tool. So our standard access control list, you can block access to a certain protocols and permit access to others. All right, so now we are able to go to the browser. Let's try to go to kca.com and see if we can reach something. And we are trying this from where? From VLAN 70. It's taking a bit longer. If it does fail, then we need to troubleshoot and investigate why is it failing, okay? All right, so let me minimize this page. We're pinging from there. So let's go to this PC. Probably we didn't request an IP address from that particular PC. So once it loads back up, we can check that. So this guy, ipconfig / renew. This is another one of the PC inside VLAN 70. So this one gets an IP. Let's see if we can ping 192.168.20.30 and see if it's reachable. So we can reach VLAN 30, what the DNS server is configured. So let's check it out. Let's see what we have there. VLAN 30 is here, kc.com is configured right there. Let's see what we've got inside. Desktop. So troubleshooting, guys, is the main job as a network engineer. So we can see that there is IP address configured 192.168.20.30.20. However, we're not able to ping it from Austin. Let's see what's going on here. Do show IP routes. OSPF. We can see that VLAN 30 is being advertised. Good. But we cannot ping from here. Let's do ping 192.168.20.1. 30.1. Reachable. Now, our VLAN DNS server is this one, 192.168.30.20. Ping 192.168.30.20. Now it's reachable. So there was some latency in the network. Since it's reachable now, let's go back here. Now the page loaded, right? Can you guys see that? This page was successfully able to load. All right, so nothing was actually wrong. It was just that there was a little delay in the network. Okay, we have another page called fakebook.com. Let's try if we can reach it. Fakebook.com is reachable. Great. Back to kca.com. Reachable. Okay. All right, guys, that's it for today's class. So we spent almost like 1 hour, 59 minutes with 50 something second. So the purpose of this lab was basically to cover everything that we've discussed so far in this class. So we cover VLAN, trunking, OSPF, DHCP, DHCP relay, SSH, and access control list. We touch base on standard ACL. All right, guys. So just a quick reminder, guys, for the people watching us from Facebook, we have a new session of KCA for Cisco CCNA training and Amazon AWS Solutions Architects coming up this April 20th, April the 20th, 2026. We're starting a new session. Registration has already started since February the 10th, and then the registration should end by April the 15th. But there are some great news, guys. If you do register by March 15, you have a 25% discount, and if you refer up to 5 people, you get 50% discount. Okay, guys, please keep watching us, keep following this page, our Facebook page. We have an Instagram page which will be communicated to you guys, and then also for those who need to get more information about the program, please call us at 512-290-6057. 512-290-6057. That was David Ngunza from KCA. See you soon. Thank you.